All right. What we're going to do today is just sort of an overview of just an assortment of printers. So I went down and took a little short video that we'll walk through. Um, right now on the screen, you just see an Ultimaker 2 Extended Plus. So these are just videos that well, printers, a video of printers that are downstairs. We can look at a variety of different styles of printers, some that we haven't talked about before. This is kind of the last official video for the summer course, and I'll continue to put videos out, but they won't necessarily be part of this course. So this one's just kind of a wrap up on a variety of other things that we didn't specifically talk about. The Ultimaker 2, that's just the first one when you walk in the particular room, so it's why we're looking at it first. There's nothing particularly special about it. Ultimaker is a good printer. A little more expensive than what the printers we've been looking at, other than that last one that we looked at, the Kitty. It's in, these can be in that price range, or some of them can even be more. It's an FDM printer. This is the Extended Plus. So you see the Extended Plus. This is the Ultimaker 2. It's several years old still. This isn't a brand new printer. But it's the Extended Plus version of it, so it's taller. This is also a printer that where the bed drops down instead of sliding back and forth, so that gives it some advantages. It's partially enclosed. You can get kits that more fully enclose these printers. Um, this one is pretty reliable for us, honestly. It's a good printer that whenever we need a part that we're not sure, or some of these other printers are going to be able to do it, we probably put it on the Ultimaker. So uh, we usually use it to print stuff like ABS. Oh, let's pause here. ABS and other materials, even PLA, but a lot of times it's printing ABS materials. This back in the background, this vase, that's kind of some foreshadowing. So it's a large vase. That's from our large printer, large format printer that we'll look at it. It's in this video a little bit later, but that's an actual print from it. So let's let's mute that audio. I don't want to listen to it yet. This printer, let's back up a little bit. Well, too far. Let's see if we can find there we go. This printer is the Mark Forged. So it is a printer. It's enclosed. It's not a heated chamber. The bed does heat, I believe. It's a carbon fiber nylon printer, but it's the one that I was talking about that um, I think the last video we looked at the Kitty XCF Pro, which is a carbon fiber nylon specific printer. It can print other materials also, but I mentioned this one, and the difference with this material or with this printer is that it prints a carbon fiber nylon. It's got this dry box back in the background. You can see the edge of it, and we actually have another one of the little Sunlu dryers over here. Um, it prints a material called Onyx, which is just their brand of a carbon fiber nylon, but that's not the unique part. The unique part's inside of it. You actually see it back here, but I'm going to open up the video or open up the printer. So this spool in the background, I don't know if you can read it because it's tiny, but that label is telling that's a spool of Kevlar. So you can kind of see I don't know if it picks up on the screen very well or not, but there's a thread of Kevlar feeding into this tube in the back. Um, and that tube works its way around. You can kind of see it over here. And you got your main filament feed here, but you've got this other feed parallel to it. And they work their way around. This could be Kevlar, nylon, or fiberglass strands. And they come out over here. So here's the extruder for it. You can see that smaller tube that's feeding in solid strands of Kevlar, fiberglass, or carbon fiber parallel to this onyx material, the carbon fiber nylon. So nylon with chopped carbon fiber in it. And so this is the printer where it can inlay solid strands of your material, carbon fiber, Kevlar, or fiberglass, in the walls of the part that you're printing. So it can make extremely strong parts, rigid parts. Whenever you do the chopped carbon fiber prints, maybe you've got it in PETG or maybe you do have it in nylon. That does make those materials a little more rigid, but this your approach, you're not at like the strength of steel or aluminum or anything like that, but you're getting there. You're getting a very strong part. Um, and so that's what's unique about this printer is that it will feed solid strands into the walls of your part. And so it has, it has its own slicer and everything to control that. But this is a really nice printer. This one's in the $20,000 range, something like that. So that's why it does similar things to the Kitty, but it's 10 times more expensive. And I believe this is one of the cheaper versions of the Markforged um, line of printers. They have some other printers that are some metal printers where you print FDM style print a green part that is metal, but still has a lot of binder, the PLA or whatever. I'm not sure what material they house the metal in, but then you treat the green part into a pretty solid metal part. But those, now we're getting into $100,000 machines, and I don't know the exact price, but they're more expensive than this one. Um, I don't know. 100,000 might be overdoing it, but I think that's close by the time you get the printer and the post processing materials. Like there's a whole setup for the kiln and the post processing that you have to do to actually turn it from a green part into a metal part. It does get rather expensive on the machines there. We do not have one of those setups. Maybe someday we'll work on that. It is interesting to be able to print actual metal parts, or at least parts that approach the same densities and strengths of real metal parts. All right, what do we have next? So this is just more video of the printer itself. Um, oh, all right. So here, two little Prusa minis. These are good printers. They are smaller. Those build volumes are smaller on them. They're cantilever style. They come mostly assembled. I would say that they're not quite as much to assemble as maybe the Ender 3. That style printer. They're in that range though of the amount of assembly. You don't have to build every little piece of it, but there's a little bit of, so basically you have to bolt the upright part onto the base and plug in some wires. Um, so these are good printers to have, just as kind of workhorse printers. They're really pretty nice printers. So we have two of those. They're not terribly expensive. I think you can get them maybe. Well, I'd have to check, but maybe in the 300-ish dollar range, maybe 400. Why don't we check and see real quick before I tell you wrong. 429 apparently. Well, that's off of eBay. Um, from their actual store, there's usually a pretty decent lead time on these things too. So let's see. I'm over on Prusa's website here. Original Prusa Mini semi. Oh, they do have a kit version also. So normally their kit versions are the cheaper way to go if you don't mind a little more assembly. So the kit version of one of these is $459. Well, that's semi-assembled, lead time 2 to 3 weeks. Maybe semi-assembled is their kit version. I'm not sure. It looks like, oh no, the kit version, lead time 1 week, $429. So more than your Ender 3 is going to be, but they are good printers. They're smaller, but they're pretty reliable. So we have a couple of those. Back in the corner there, you can kind of see stacked up. Those are old MakerBots. Um, that's what they're good for right now. Is we've mainly parted those out, so they're just kind of in the corner. They're used to keep everything else running these days. Nothing special about that particular printer there. That's just the Ender 3. Actually don't. It looks like it does have the touchscreen, so it's probably got a SKR Mini E3 running it, and it's got a BL Touch on it over here. So that's pretty ordinary. That's basically what we've been using the whole course. This one's different though. So Ender 3 again, but it has a water cooling upgrade. So let's see, I think there might be a little bit. There we go. So you got a water pump in the background, feed and a return line going into a cooling block over here. So this one doesn't have a not a part, a hot end cooling setup like a fan blowing on it. It actually cools with water. So this one you're wanting to print much hotter temperature material. So it's all metal hot end, direct drive, and water cooled. It does have a mount for some part cooling fans, but usually the materials that we're printing on this one don't need part cooling. They actually behave badly under part cooling. So we kind of just leave that off. It looks like there might be a spot for a BO Touch that would be there, but it's not on there right now. But this one is kind of just almost just for fun. Um, I don't remember the name of what water cooled block this is. I made a whole video on it last year, I believe. See if I can figure out which one that one is. Um, well, I don't see it easily. I'd have to go find my own video, I suppose, to to find out which hot end this is because I don't remember it. Um, I don't I don't see it right off the bat. Yeah, well, if you're interested, there's a video that I made last summer, I believe, maybe 2 summers ago actually, on this setup. Actually, we kind of built this setup last summer or whenever it was. So it's just a kind of a for fun thing. And if you really needed to print some peak or something that has a really high temperature, this is a way you might could do it. Um, it's not particularly practical for most applications though, so it's just for kind of um, this printer, another unique printer. So this is the same smart version. This is a belt printer. So I think in a minute I'll point out the belt. Yeah, right there. That belt, on your Ender 3, your bed slides back and forth, or that Ultimaker that we looked at the beginning, the bed drops down. Um, this is a conveyor belt. So it's just like a conveyor. There's a roller at the front, a roller at the back, and this belt rolls in a continuous loop. It's very slow, but rolls in a continuous loop here. So you effectively have an infinitely long bed. It's fixed width and there's a limited height, but infinitely long. I think I come around to the side here in a second. Let's see. Yeah. So you can see the nozzle is at a 45-degree angle. So when it's printing parts, the nozzle kind of stays in this plane defined by these 45-degree braces or rails. And you can see where it rolls on the rails here and here and back here. And the belt inches, or millimeters forward until your part is complete or until it just falls off the end of the bed here. It just keeps going. So you can, that's a very blurry spot to stop. Let's go there. Um, so the idea with those belt printers, and there's a couple of versions now. They're relatively new as a commercial product. Maybe 2 years at the most that of when you can have bought one of those. There were people experimenting with them um, for several years, and then finally Creality released one. That one was from Sane Smart. There's probably a couple of others now, and it is if you have really uniquely shaped, long. You want to print a sword, something like that, or you want to kind of set it up on a auto repeat cycle. So you print a part, it skips a space, prints another of those parts, skips a space. You can just print assembly line almost. Well, not assembly line, but manufacturing line of parts, and just let them fall off the end into a bucket. They're a little on the high side. I bet they're probably in the $700 range now. Let's see if I can find one. Oh, well, that particular one, or the current version of that particular one, looks like it's $1,000. There is a smaller one. The one that we just saw in the video is $650 right now off of Amazon. Um, and then there's a little bit larger, more modern, or well, updated version that's in the $1,000 range. This guy is a custom print company called Rectify. So this direction here, that's 6 feet, that's 4 feet, and that's 4 feet. So it has a huge printing volume. You can actually see the roll. Actually, probably about to zoom in on the roll back here. That's a 5 kilogram roll of material. That vase at the very beginning of our video came off of here. It does have a heated bed. You can kind of see the places where there's some nichrome wire embedded in here. This variac, this red cylinder over here, that's a variac for controlling the heated bed. It doesn't, it's not really practical on heating a 6 foot by 4 foot, 24 square feet of bed. But if you had to, I suppose it will, we do have it where you can heat it. The idea with this one is we don't print with this one a whole lot yet. The idea is that we'll have zones where if your part's mainly over in this zone, then you heat that zone. You don't try to heat the entire bed. This one, like I said, it did come from a company, Erectorbot. We've heavily modified. It's got a super volcano hot end on it. We changed out the control board for a Big Tree Tech Octopus. We're working on modifying this heated bed to make it at least sort of usable. So it does have dual extruders on them. They're not independent. They are tied together. We don't currently have the second one on here, but it can print two. This one, the idea probably should be it prints one that is a very large diameter nozzle, so kind of your backfill and infill, inner walls type stuff, and then another nozzle that is a more fine detail one for the skin that you're going to print. Although, even with this super volcano on there, we've been getting, for that size, what I would consider good surface finish. So that's this guy. Over here, this is not a printer. This is actually a little desktop water jet machine that we haven't completely installed yet. It was in another room and it's getting relocated over here. It'll probably sit kind of over in this corner when we're got it set up. See what's next. There's the 5 kilogram roll that you feed this thing. This one is a unique printer. Well, there's three things here in a row, kind of. There's no one in this lab right now, so things are a little bit disheveled. In a few weeks, we'll have some workers down there and get it all back in order. But this printer, it prints wax. It actually prints two waxes. So the idea with it, it's really a jewelry printer, or something that needs small details. The idea is that you print in wax, and there's a process for metal casting called lost wax casting, where you take that wax part that you've made, in this case you've printed it, you encase it in a investment, so like plaster, then you heat it up so the wax melts out and you're left with a cavity, the shape of the wax in that plaster, and you pour in molten metal and remove the plaster, or the investment. It's not actually plaster, but it's similar material. And so this printer, it's a little bit old now, probably, I don't know, 5 or 7 years old, somewhere in that range. It's one of the earlier ones that could print directly in wax. You can get, if I can think of the name of the company, I can't think of it right off the hand. I'll look it up. But you can get wax filament, actually. See if I can find the name. Machinable Wax is the company that makes this stuff. Not this printer, but the filament. This is a 3D Systems printer, I believe. So you can actually print, you're going to get not nearly the resolution that you would get off of this printer, but you could print wax off of your FDM. There are wax castable resins that you can use in the little resin printers. And so you can do some alternatives to this. None of them get to the detail that this thing gets down to. And it has two wax materials, so one of them can be used as a support, so you can print overhangs and things like that. But it's a very specific application again. Let me see if I can find, I think I have some samples. So here, this is an older one, so it's kind of gotten kind of bad. But this is a tiny little, well, 2-cylinder engine block, all cast in wax. I mean, the detail level off of that machine. So this one never got actually burned out through the wax lost wax casting process. It's just kind of our sample that show off whenever I want to show the level of detail, types of detail you can get. Um, this didn't come off of the printer. This is actually a aluminum, a little Millennium Falcon that was cast. This one actually was cast from a a castable wax from a resin printer. It didn't come off of this particular printer. It's just using the lost wax process that you can create actual metal parts. So next to this, there's the original palette from Mosaic. It's one of the multi-material. You put four materials in, it splices them together into a single material, so and feeds it to your single nozzle extruder for multicolor parts. Got an old Delta back here that this is from Me CNC, I believe it's the Delta, the manufacturer of that Delta printer. It needs some work, so it's down out on the floor. What else do we have here? Just a closer view of the SolidScape uh, printer. There's the Mosaic palette. Uh, oh, up on this shelf is a couple of older resin printers, and a washing cure station. This little set is interesting. So these are printers. Not necessarily, I wouldn't call them 3D printers. I haven't get a clearer one to pause on. These are circuit printers. So these boards sitting on top here, these start out as just blank fiberglass boards, and you put nozzles. There's actually one. I can't tell what that be a drill. Can't tell what's in that one. Um, but you put a syringe basically in the holder, and it prints conductive inks onto these circuit boards. Um, this says hot surface because it's also a reflow station. So you print your conductive ink, you place manually. It doesn't. These machines don't have like pick and place where they go grab the parts, but you place your elements on them, your PCB chips or your LEDs, resistors, whatever you have. It's all surface mount type stuff. It can do through hole. There is a little drill attachment where it can drill holes into the base board. But the idea is that you can prototype circuits really quickly. So I think in a second I'll take a 9-volt battery and go there. One direction, two LEDs light up. Other direction, the third one lights up. So um, just as a little sample that, well, you can even see it's the Hello World sample for these printers. Basically, it's the first thing you do when you try to get one of these up and running. But all of this would be a completely blank green sheet, and all of the silver was printed by the printer, and then the actual electronics are surface mount electronics that you manually place there, and then you put it on the bed, which I don't know if I have another view of the bed. There's one. Well, a blurry one. You put it on the bed here and reflow the solder to melt everything together. It's not. Let's see if we can get it where it's not as blurry. We'll pause on the MakerBot. Um, it's not as conductive as pure copper or something like that, but it lets you test things out um, layout wise and things like that, or do a really quick circuit, a mock-up. This is a MakerBot Z18, so it's a enclosed. It's a nice printer, but the problem with the MakerBot stuff ends up being that it's all proprietary. So if something breaks, you can't really easily fix it yourself without voiding a warranty or everything. So this thing is down. It's not running. But it is a nicely done printer, but it's just difficult to maintain because of I can't just go in and replace a part without getting an official part from MakerBot. There's a little Lowesbot Mini sitting beside it. They're another good printer. Let's see what's the price on these things. I think they're in the $1,000 range. Well, $1,500 range. Well, this is a Mini 1. They actually have a Mini 2 now, and they look very similar, but the Mini 2 has a little control panel up in this corner. These are good printers. They have almost the opposite mindset here. So whereas everything's proprietary, you can't fix stuff easily on the MakerBot. In fact, I did this 2 weeks ago. One of these parts breaks, you go download the STL file and print another one. And that this is an open source printer. You could, if you had all the time and all the right little, way to make the metal parts, you could print your own version of this thing and create your own. And they're really good printers. We usually have these. I believe both. We have two of them. I believe they're both set up with 3mm filament, and they're direct drive. At least one of them is direct drive. I don't remember if they both are. So we use them for flexibles and stuff like that a lot of times. I can't tell if that's a flexible material that is loaded in it right now or not. Um, I think that was the end of our tour. Let's see if we got anything else. Well, all right, there's two. They're going to be blurry. Oh, let's see if I can get a. Well, I think I'll only have them in passing. Here's a little Cetus. I like these printers, but it's got linear rails. It's in the, I don't know, $300-$400 range. It's another one that's the same. It came out before the Prusa Mini. Um, they're decent little printers called a Cetus, Ceetus. This little guy over here that's the polisher. So I don't know. It's been maybe a month ago now. I talked about a filament that would smooth with isopropyl alcohol. This is the official polisher for that material. So it's got a little nebulizer in the back that nebulizes your isopropyl alcohol into this chamber here. It's got a little rotating table, and your part sits there and gets kind of vapor smooth. It only works with that filament that can smooth by IPA. It's not one of the acetone smoothing. I'm not sure acetone would do well in this chamber or not. I think it might mess up some of the chamber. I think we're at the end of our tour. Yeah, there's the exit door, and there we are back at the beginning. There's that vase I was talking about from the really large printer. So that's kind of a overview of a different set of printers. There are a couple of others down there that we didn't go look at. There's a 350 by 350 by, I don't remember the height, but somewhere in that range, Voron 2.4 down there. It's a high-speed printer. We looked at the little mini Voron a little while ago. This is just a much bigger version of those. Those are, I would say, if you want to learn about printing, that's a good way to go about it. It's a little bit expensive, even for the mini, in parts, but you build everything. Like you print the parts that are the connectors and everything. You print most of the hot end assembly, and then get one of the kits that's already kind of put together as far as nuts and bolts and steppers and things like that, and you will learn all the pieces of a printer. And they're good printers in the end. They're Core XY printers, so they're made for very fast, high-speed printing, and they work really well. And if you want to learn about all the little nitty-gritty, everything you have to do with FDM printing, that's a good way to do it. If you just want to print, maybe you're going to have to build the Voron. You can't just go buy a Voron. You might find somebody selling a assembled one that they're getting rid of, but that's going to be rare. The most likely thing is you're going to have to find a kit, at least, if you don't just go source all the parts yourself, and print the connectors and the brackets and everything, and assemble it yourself. But it is a good way to go if you want to learn about printing. If you want to just print, that's probably not the best way to go, because it's going to take you a while to get everything printed, get everything adjusted, assembled. It's a learning process. All right, so hopefully that was a little bit of good way to wrap up everything and get an overview of some of the things we haven't really looked at before, some of the sort of unique printers. Like I said, I'll upload periodically new videos. Maybe I get some new filament in. I still haven't printed on the chocolate printer, so I still need to get that thing printing. And there's a couple of materials I showed last time that I want to print on this Kitty printer, the XCF Pro printer. Some polycarbonate materials mainly, and see how they come. Oh, I did print. Remember last time I wanted to print the PMMA, the acrylic. I did print it, but I turned on cooling 20%. I think I did 20 or 25% cooling, so very low, and it looked great. But this is what it looks like now. There's no layer adhesion. So this is kind of interesting to see the vase mode. There's how vase mode works. You can kind of see the spiral. So um, it looks nice, but it actually didn't hold up. As soon as I actually taking it off the bed, kind of ripped it all apart. The base is really solid though. So the part where there wasn't cooling is super strong. It just doesn't look as good. So I think I'm going to have to print one, um, no cooling, like it said not to do cooling. I just wanted it to look better. Maybe if I go slow and maybe over extrude a little bit, I can get a clear-ish looking print. I don't want to print it while I'm in here though, or wherever I put the printer, because the PMMA fumes, even for that one, for a short print, was they're just a little too much, even in a printer that's enclosed. So it really needs a scrubber of some sort if you want to print materials like that. The fumes are just not good for you to be inhaling for long periods of time. So I'll print it overnight when I'm not here, and let you know how that turns out. There's a couple other things I want to do still, but this is the last official course video. So if you're taking the course, then this is the last one of them. All right, I will see y'all next time.